Good evening, everybody. Tonight we'll be learning about sigma notation. So let's get started. Recall, what is a sequence? A sequence is a list of numbers, such as ta-da, T1, T2, T3, all separated by commas. Whereas a series is really just the sum of these terms. Okay? Get it? Got it? Good. Alright, let's move along. Now, the series, the sum of all this stuff here, can be written in a shorter way. But the series or sum can be written more compactly using what we call, wait for it, sigma notation. What is sigma notation? Well, let's take a look here. We've got T1 plus T2 plus T3 plus ... plus Tn equals this Greek letter here of the alphabet. It's called sigma. And really, you've got, well, let's figure out what these pieces are here. Let's say k equals 1, and then up to n, and this is t sub k. Okay, so what do each of these things represent here? Well, remember that this sigma here, this funny looking e kind of backwards, means sum. That's all it means. It just means the sum. It means all the pluses there. And what does n mean? N means, ding! It means the upper index of summation. While k equals 1 is, ding, the lower index of summation. And meanwhile, tk is just kind of like your, I guess, your individual term. So I'm not really set apart with a special name, just leave it as such. Now, something important to know, the number of terms, really n, like how many terms, is given by this formula here. Ding! Upper index minus lower index plus 1. And let's highlight this for good measure because it's, oh, that's not highlighting. There we go. Upper index minus lower index plus 1 is the number of terms. So think about it this way. Let's say that I had the numbers from 3, 4, and 5. And I ask you, how many numbers is that? And you would obviously say, well, Miss Yang, that's easy. It's just 3. You just count them. 1, 2, 3. Yes, that's correct. Now, but if I was just given numbers 3 and 5, you might just say, well, 5 subtract 3 is just 2, and you would say there's just 2 terms. But no, really, you're not. There aren't 2 terms, there are 2 gaps. But the number of terms, you always have to add 1 to those gaps. So 5 minus 3 plus 1. So just remember that, okay? So if I were to use the general form, I guess, for this number of terms, I guess you can say it's really upper index, which is n, minus lower index, which is k, and then add 1. N minus k plus 1. Now, I do want to provide you with one caveat, which is kind of a warning. This formula here, n minus k plus 1, isn't really I don't think you should memorize this and use this always. Just memorize the formula upper index minus lower index plus 1. So whatever is up here on the top of this sigma, you take that number, subtract the lower index, and then add 1. Okay, because this can be a little bit confusing, n minus k plus 1, so I wouldn't really go by that. Alright, let's move on to some examples. So let's scroll down. Example 1. Find the sum of this. Okay, so let's see how this sum thing works. So what you want to do is, I would just put an equal sign. And we know how many terms there are. There's k from 1 up to 5. They're all integer values, so 1, 2, 3, 4, 5. So there are 5 terms. I'm going to write them all out. So this is what we're going to do. So I'm going to start with my lower index, so k equals 1. So I'm going to plug in 1 into k, like this, and then subtract 3, so just copy that. And then plus, because that's where the sum comes in. And then I go up to the next index, which is k equals 2, and then I sub that into k, so 2 minus 3, and then plus, oops, I'm going to run out of space here. Let's go on to the next index, so 1, 2, and then the next number is 3, minus 3, and then plus, okay, where are we at now? 4, okay, 4. So 4 minus 3, and then plus, and then, oh, that's our last index. The upper index is 5 minus 3. That's when I stop, because I've basically written out all the numbers from 1 to 5. And then we just evaluate this and see what we get. So you get negative 2 plus negative 1 plus 0 plus 1 plus 2. And what do you know? All these cancel out and you get 0. The final answer is a big fat 0. Or maybe it's skinny. Depends how you drew it. Okay, so that's basically example 1. So 1A, why don't you try 1B? Please pause now. And thank you for pausing. Okay, so let's evaluate this. So our lower index is 1, so we start from 1, go up to 4. So here, there are only 4 terms. Just notice that these upper index and lower index indices are quite small, so we can just write them all out. So let's start off with 1. So k is 1, so let's plug it in. So 1 squared minus 1 plus. Okay, next index, 2. 2 squared minus 2 plus. Next index, 3 squared minus 3 plus. The next index, which is 4 squared minus 4, and that's it. That's our upper index, so we stop. And we just evaluate this, so that's 0 plus, what's that, 4 minus 2, which is 2, plus 9 minus 3, which is 6, plus 16 minus 4, which is 12, and then we add that all up, and we finally get 20. 20 is the sum, right there. Okay, why don't you try the next one? It's a tricky one. Okay, with this one here, you'll notice that there is no k in the general term, or, inside here. So if there isn't, then I can't plug anything in, so all I can really do is just write this number for when k equals 1, that's the first term, 7. Plus, when k equals 2, well, it's still at a constant, it's still 7. And then when k equals 3, it also equals 7. And I stop because my upper index, I've reached it, so I stop. And so 7 plus 7 plus 7 is unfortunately not 777. It is actually 21. 21. Okay, good. Let's move on to the next one. Example 2. I like these questions, don't you? Isn't math fun? Math is really fun. It is. If you just only give it a chance, Okay, so what are we going to do here? I guess what I like to do is I write out the first few terms, and then I write the last term out, so then I kind of see what's happening here. So before we even do anything, I'm going to write in when k equals 1. So let's do this. 2 times 1 plus 1. Okay, I'm just going to write out the first couple terms. So that's the first term. Second term is 2 times, and now this time k is 2 plus 1 plus, okay, let's do 3 like this, plus dot 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 plus, and this time let's do the last term when k equals 100, which is 2 times 100 plus 1. Okay, so evaluate this. I'm going to take 2 seconds to do this very quickly. Give me 1 second. Okay, so welcome back. When you expand this, I guess, you will notice that this is an arithmetic series, because we've got a common difference of how much? What is it? It is 2. So that's our d. So d is equal to 2. What else do we have? We've got our first term, which is the a term, the beginning right here. A is equal to 3, right here. And our last term, right here, is 201. So last is 201. And we also have our n as well. N, which is upper minus lower plus 1. So 100, let's do this. N equals 100 minus 1 plus 1, which is just 100 terms. And you know what? We have enough information to actually solve this using the formula from here. Remember this? The formula right here. Sn equals n over 2 bracket a plus l bracket. So we're going to use that one because I think we have all those pieces of information. So let's set it up. Okay, so I'm trying to set this up, and I've got this formula, and I'm going to use this. So S100 is equal to 100 over 2 times the first term, which is 3, plus the last term, which is 201. And you do this math, and you shall get, boom, 10,200. All right, on to the next question. Or would you like to try? Please try and come back and pause. Or pause and then come back, I mean. That makes more sense. All right, I'm ready. So let's write out the first few terms to get an idea of what's going on here. So first, the k value is 3, so 3 over 2. Plus, okay, next one would be 4 over 2. Plus, the next one would be 5 over 2. Plus, dot, dot, dot. Plus, the last term would be 52 over 2. Okay, let's see here. Let's see what we got. All right, hopefully you would notice that going from one term to the next, you are adding by a factor of half. So D, common difference, is half. This is an arithmetic, okay? Arithmetic series. Okay, what else do we know? N. Our N is upper minus lower plus 1. 52 minus 3 plus 1, which is 50. Okay, what else do we know? We know that our last term is, last term, let's do first term. A is equal to 3 over 2. Our last term is 52 over 2. I think we have enough information to solve this. So let's do it. Okay, so we're going to use this formula again. So S100, 100, where did I get that from? Oops. I meant S50. S50 is equal to 50 over 2 times the first term, 3 over 2, plus the last term, 52 over 2. Okay, when you do all this math, you should get 1,375 over 2, or if you put it as a decimal, 687.5. Oops. Okay. Now I'm going to show you a different way, and I much prefer this way because I think it's a little bit more efficient, but you be the decider of that. So let's do this question again. I'm going to erase this. Give me 1 second. Okay, so now notice that there are halves in each of these terms, and suppose I factored out a half from each of these terms. Okay, then you end up with just 3 plus 4 plus 5 plus ... plus 52. And then now I just need to find the sum of all this stuff in the brackets, and whatever it is, it just times it by half. So let's identify all our key pieces of information. Okay, so this time we've got our first term is 3, our last term is 52, our N is 50 still, our D now is 1. So let's figure out what this is. So S50 equals 50 over 2. A is 3 plus 52. Okay, if you do this math, you will get 1375. Now that's not the answer, because this, notice here, 1375 replaces all of this stuff here. That's what it's really, that's the answer for that piece. So if I were to sub this in, really the answer is half times 1375, which is, 1375 over 2, or 687.5 as we got before. Okay, moving along. So there are two ways of solving that previous question. I tend to favor the latter one because I find it a little bit more efficient. You choose however method you like, as long as you get the correct answer. I think that is what is the most important thing. So the next example here, let's take a look. Why don't you try this? Give this a try. Just start plunking in numbers for I equals starts at 1, and then do a couple, maybe I equals 1, and then 2, and then 3, and then maybe 15, and see if you can figure out the sum of this, whatever this is. Alright, so this is what I'm going to do. I see there's a factor of 8 here, 8 times whatever all these terms are, so I'm just going to take out an 8. And then basically do this. 8 times the sum of whatever I equals 1 to 15, and then 2 to the power of I minus 1. Okay, so that's what I'm going to do. So basically find the sum of this stuff here, and then times it by 8. That's the answer. So let's start writing out the first few terms. Okay, so this is what I get. I'm just substituting in I equals 1 to 2, 3, and then up to 15. And it doesn't matter, no, in previous examples we had I was really K. I is just a variable, it doesn't matter. Okay, now I'm going to simplify this and see what we get. Okay, I think you'll quickly notice that this is not an arithmetic series at all. If you look from one term to the next, 1, 2, 4, I think you can see quickly that we're actually multiplying by a common ratio. And what is that common ratio? Well, what I'm going to do to find the common ratio is I'm going to take the second term divided by the first term, which is 2 over 1. So my ratio is really just 2. So R is 2, our first term is 1, our last term is this guy right here, 16,384. And let's see what kind of things do I need to figure out the sum. Oh wait, do we know what n is? Yes, n is the upper minus lower plus 1. So 15 minus 1 plus 1, which is 15. I think I have enough information now to actually find the sum. Let's take a look. Okay, so I can use either of these equations for the geometric series, Sn. Either is fine. I will probably just use the first one because it's the first one there. Okay, so on the side here, I'm going to find out S15. And then remember, don't forget to multiply your answer by 8. Okay, so S15 is this, A minus RL over 1 minus R. So plug it all in, this is what you get. So you end up with S15 being 32,767. We're not done yet though, because remember, that's only what's inside, what represents. It represents all the stuff inside the bracket, so let's just substitute it in. All the stuff is really just equal to 32767. So our answer then becomes 8 times 32767. And so the final answer is 262,136. Voila, there you go. Let's move along. Example 5. Why don't you give this a try? This is a good time to stop and give her a try. Give her a whirl. Alright, so I'm going to factor out 5 because, you know what, this just makes life a little bit simpler for me. And then I'm going to expand this, see what it looks like. Okay. This is what you get. And further simplifying it, let's see what else we get. Okay, so you get this. And this is, you can see, a unique series because our upper index is infinity. So what kind of series is this really? Well, let's take a look at our R, our ratio. That's kind of important to tell first, whether this has a sum or not. So this is definitely going to be an infinite geometric series. Whether it converges or diverges depends on our ratio R. So let's calculate R. Okay, so now remember, R is calculated by taking the second term divided by the first term. So I took negative 1 over 8 divided by 1 over 4, and I wrote it like that. Then I'm going to flip the second fraction, and let's see what we get. Alright, so our ratio is negative 1 over 2. And remember the rule about a converging series, infinite geometric series. Remember, the series has a sum as long as the absolute value of the ratio is less than 1. And indeed, in our case, it satisfies this condition, so you know that this formula here will work. Alright, so let's plug in all our values. Our A and our R is all we really need. So we know our A, our first value, is 1/4, and we know that our ratio is negative 1/2. So let's plug this all in. Okay, so I'm plugging in all my values, and you got to be very careful at this bottom here. In the denominator, there are two negatives. One's a minus, one's a negative, and when they're together, two wrongs make a right, I suppose. So really, this is 1/4 over 1 plus half, which is 3 over 2. And now it's just a matter of simplifying this. So let's do this the old-fashioned way without a calculator. Okay, so I've written it like this: 1 over 4 times the reciprocal of 3 over 2, which it happens to be 2 over 3. There's some nice cancellation here. The 2 and the 4, you get 1 over 6. Now, don't forget, that's not the final answer. That's only the stuff in the brackets, right? This stuff, 1 over 6, is really what this is equal to, this stuff in the bracket. So I must multiply it by 5, this red 5 that's on the outside. So the final answer here is 5 times 1/6, which hopefully you can do that without a calculator, because if you can't, that's kind of sad. Alright, so 5 over 6 is our sum of this infinite geometric series. Alright, moving along, let's go on to the last two examples here, right, using sigma notation. So it's kind of a backwards question. Alright, let's see how we can set this up here. Alright, okay, so this we need to figure out is this an arithmetic series or is this a geometric series? So the hint is up here. There's a 10, there's an exponent. Usually that means it's going to be geometric. So let's see what our ratio is. Our ratio is equal to second term, 4 over 9, divided by the first term, 2 over 3, which is, let's just do this very quickly. Get that, and then get that, and then finally our ratio is 2 over 3. Oh, okay, yeah, this is definitely, oops, that's what I boxed at. That's definitely our ratio. So let's see if we can do this. Okay, so our sigma, and let's use k. K equals, now it's going to have something to do with 2 over 3, for sure. Now, the first term is 2 over 3, so I have to have k in the exponent such that whatever the first term is, whatever this number is, k equals whatever, has to match, so when I expand it, equals to 2 over 3. So you know what? In order for 2 over 3 to the k equal 2 over 3 as the first term, k must be equal to 1 as our first, our lower index. And our upper index, well, kind of the huge clue up here. Let's highlight this here for you. Right there. Since k starts at 1 with the first term, then it's really simple. Our upper term is really k equals to 10. Okay, so that is the answer. And if you're not sure, you can always expand this out to just to double check, because, you know, why not? It would help. It would help. So let's do this. Let's plug this in. So k equals 1. Let's see. So 2 over 3. K is 1. Okay. Plus next term. 2 over 3. And then it would be squared. Plus 2 over 3. Cubed plus dot 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 plus our last term, 2 over 3 to the power of 10. And you know what? Indeed, this works. So I know this is good to go. Right, next one. Last one. Now this one, you have to ask yourself, is this an arithmetic series, or is this the other one which is called the geometric series? It's late. Give me a break. Okay, 1 second. Let's pause. Well, this is what I noticed. Each term is increasing by 3, so this is going to be arithmetic. So let's identify some other key features here. Okay, so I've identified all these things here. I have A, I have T of N, our last term. I've got D, but I don't know N. So let's, you know what, let's just use this formula here. From the very beginning, Tn equals A plus bracket N minus 1 bracket D. Let's just do it. What else is there to do, I guess? So Tn is equal to this. So let's use this formula. Tn is really 130, and A is 4, N is I don't know, and D, our difference, is 3. So let's expand this and let's see what we get. This, and then we get this, and then we get this, and then we get N is 43. So there are 43 terms. Okay, so now what? Well, let's use that sigma notation here. This is a lovely sigma notation. Sigma notation, and use k equals something. Figure the lower index and the upper index. We know the upper index is going to be 43 because we just figured that out. It goes up to 43 terms. And I guess that's if you're going to start from 1. So k equals 1 to 43. So there are 43 terms from 1 to 43. And then we're going to put in for the general term. Well, I guess let's use this here. Let's use the general term for Tn, which here we've identified is actually all this stuff right here. So 1 plus 3n, and I'm going to rewrite it so that's 3n plus 1, like so. Alright, let's check to see if this is true. So let's just expand it, put in 1 into n, so 3 times 1 plus 1 is the first term, plus, the next term would be 2. 3 times 2 plus 1, plus, dot dot dot, and then, oh, running out of space here. Let's do last term. Plus 100, not 100, plus, what is it? 3 times 43 plus 1. Okay, let's see, what does this become? And indeed, it is actually what our original question is. 4 plus 7 plus blah 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 plus 130. So you know what? You know you've done this right. It's a good check. And give yourself ding check mark. And thanks for watching. That is sigma notation. Bye bye.